Hello, today is Thursday, October 6th, 2022. I skipped several days of reading of my daily English reading, but here I am back again. And yesterday, the Academy Nobel Prize Academy announced the three physicians for this year's award, and let's find out who they are. This one is from science.org. Science Insider, People and Events. Trio who proved quantum mechanics is really weird and useful, honored. New laureates aid groundwork for entire field of quantum information science. 4th October 2022, 6:25 a.m. by Adrian Cho. Cho, you sounds like Korean. I'm Korean, and we have name Jo, and Jo is spelled not J-O, but C-H-O in Korea. So I think you are Korean. I am learning Chinese, and there's no name Cho, but Zhao. Zhao is close to Jo. So I'm definitely sure you're Korean American. Nobel Prize in Physics winners John Clauser left, Anton Zeilinger center, and Alien Aspect right. Wikimedia CC by SA 4.0. Matthias Rather Picture Alliance via Getty Images, famous stock images provider. Wikimedia. Okay, thanks for everybody. I'm trying to read this article to practice my English and get a review from viewers like you to see how I am doing. It's purely academic effort. In a citation many physicists expected for decades, this year's Nobel Prize in Physics honors three researchers who proved a weird quantum mechanical phenomenon called entanglement, paving the way for the burgeoning fields of quantum communications and quantum computing. My company, Katie, is rolling out quantum communications and quantum computing products. And they received award. These three guys received award for quantum entanglement. Two of them, John Clauser of J.F. Clauser and Associates, and Alain Aspect of the University of Paris-Saclay and the Polytechnic Institute of Paris, proved quantum entanglement, which Albert Einstein derided as spooky action at a distance, cannot be explained by more intuitive classical physics. The third, Anton Zeilinger of the University of Vienna, showed how entanglement can be used to, for example, teleport information from one subatomic particle to another. The three share the 10 million Swedish kroner, or $1 million, close to $1 million price equally. So the award is rather small. So they would get just slightly over 300,000 US dollars. That's about 4억 원 in Korean. But they have to deduct 25% or more of the tax from the award prize money. I am absolutely thrilled, says Adrian Kent, a quantum physicist at the University of Cambridge. The recognition is overdue for these giants in the field. Ronald Hansen, a quantum physicist at the Delft University of Technology, says, "It's a beautiful prize. The laureate's work has basically opened up this whole field of quantum information science and technologies," he says. The tale of entanglement stretches back to 1935 and Einstein's discontent with the contingent nature of quantum mechanics. Quantum theory states that the properties of an object, such as an electron, depend on how the thing is measured. Precisely measure the electron's position, and its momentum becomes uncertain and unpredictable, and vice versa. So it can have a definite position or momentum, but not both. Einstein insisted that the particle's position and momentum ought to be elements of reality that exist independent of being measured. He suggested behind the veil of quantum uncertainty, hidden variables predetermine those values. In 1964, British theorist John Bell proposed a test of that idea. Bell noted that two quantum particles can be entangled so that even though the state of each individual particle is uncertain, their two states are entirely correlated. For example, a photon can be polarized horizontally, vertically, or according to quantum mechanics, vertically, both ways at once, which leaves its polarization uncertain. Man, both at once, that's weird. However, two photons can be entangled so that even though the polarization of each is uncertain, they are guaranteed to be polarized in the same way. Interesting stuff. Weird. Roughly speaking, Bell imagined two observers, Alice and Bob, sharing entangled pairs of photons and comparing their measurements. Each has a polarization analyzer that can be randomly oriented, and when the two analyzers aren't aligned, the correlations between Alice's and Bob's measurements drop to less than 100%. Still, Bell showed that if hidden variables determine the result of their measurements, the remaining correlations can only be so strong. But quantum mechanics predicts they will be stronger. If experimenters could observe those correlations, then surprisingly they could disprove the existence of hidden variables. In 1969, Clauser, then at Columbia University in New York, led a team that redefined Bell's general idea so that it could be applied to an actual experiment with calcium atoms. In 1972, he and other colleagues performed the experiment, observed the extra strong correlations predicted by quantum theory, and proved a first test of Bell's theorem. So that's good word, theory. Okay, it doesn't have an article there. No the. So it's a quantum theory and also theorem. Okay, theorem. Theory, small theory. Okay, theorem, small proposed ideas, proposed thesis. Such experiments are tricky, however, as they require ruling out all influences that could allow the output of one analyzer to affect that of the other and produce spurious correlations. In the 1980s, Aspect and his team performed much redefined versions of the experiments, including modifications such as effectively choosing the analyzer's orientations only in the nanoseconds after the photons were emitted. However, it wasn't until 2015 that Hansen and his team performed a so-called loophole-free experiment. If closer an aspect used entanglement to prove that quantum mechanics is every bit as weird as advertised, Zeilinger pioneered the use of it as a tool. For example, in 1998, his team showed how it could take two pairs of entangled photons and swap the entanglement so that one photon from the first pair ends up entangled with one photon from the second, a technique that could prove essential for connecting distant nodes in an unhackable quantum internet. Interesting. Distant nodes, unhackable quantum internet. I thought the I in the internet should be capitalized, but it's a small letter. Zeilinger's group also showed it could use an ancillary entangled pair of photons to to instantly transfer, to teleport the exact quantum state of one photon to another. Yeah, I'll cut it short right here and come back to the second paragraph, the later paragraph, when I get back home. Now I have to go to work on foot. Yes, I commute by foot. So I have to go and come back and connect two video recordings together, merge them, and upload it on YouTube for your comments. Thanks. Bye-bye. Hi again. I am back from work again. I'm just lying on my bed and trying to read off the rest of the story. Such work seeded the growth of quantum information science and quantum computing, booming fields that seek to use entanglement and other effects to perform technological feats unobtainable with classical electronics. Such potential was hardly clear decades ago, notes Jian-Wei Pan, a quantum physicist at the University of Science and Technology of China, who was Zeilinger's graduate student in the 1990s. Many years ago, people didn't think quantum information was real science, he says. Information scientists did not like it, and pure basic researchers also didn't like it. Now, it is perhaps the hottest area in physics. As much as this year's prize celebrates the potential of quantum information science, it also underscores a prize that was never awarded. John Bell should have been recognized with a Nobel Prize, Pan says. Unfortunately, quantum information science had still not yet emerged when he passed away. Bell died in 1990 at the age of 62. With reporting by Jacqueline Kwan and Dennis Normally. Related articles from Science, Long Distance Free Space Distribution of Quantum Entanglement. Quantum entanglement bits step closer to IT. Quantum optical rotary dispersion. Quantum entanglement of higher angular momenta. Demonstration of blind quantum computing. So what words, phrases, sentences I remember? None except quantum mechanics, information science, Pan, Cho, the Korean name, and what else? Yeah, polarization, both at once, teleport, Nobel Prize award, Nobel Award Prize, almost $1 million shared by three equally. Momentum, what else? Nothing. So that's it. Thanks for listening. Take care. I will be back with a new article tomorrow morning. And tomorrow morning is a Friday. So ciao for now. Take care.